How many of you lot want to be scientists? How many of you lot want to be mathematicians? Oh, come on. How many of you want to be astronauts? See, this is really important. And do you know the best thing? Do you know the best thing? It's you girls saying that you want to do it. That's fantastic. And what this is about making you excited about science. Giving you the opportunity to get excited about science, about maths, about engineering. And what we hope to get out of it is that when you become secondary school students, you can come up here and you can still be excited by science. And you can still learn from these fantastic people from what is one of the world's very top universities. And then what we want, what I want as a head teacher, is I want to get as many of them and as many of you, when you've gone through Imperial College and you've done your degrees and you've done your second degrees, I want you coming back and teaching. All right? So that's all I want. I want all of you signing up to be teachers, all right, in 20 years' time. Because I want you teaching you in the future. Apart from you two are going to be astronauts, obviously. So we'll have a link up with you in space. Anyway, thank you very much for coming. Thank you to all our guests for coming today. Most importantly, thank you to Lord Winston, who now is going to do some stuff with that box, I think.
What we're going to look at today is whether things can be a liquid and can there be other forms as well. Now, for example, we're all living in the atmosphere. We're breathing in what? Yeah. Air. Yeah. What is air? A gas, exactly. So things can be a liquid, they can be a gas. Can there be anything else? They can be a solid. Yeah. So these bananas are relatively solid. Now a bit fluid as well, actually, if you squish them. So really, what we're going to look at are what we call the states of matter. That is how things can change from a liquid to a solid to a gas. And it turns out that pretty well everything, there are a few exceptions, can be all three at different stages, and they depend on one or two critical things. There's actually also a fourth stage when things get very, very hot. That gives you a clue as to what changes a liquid to a solid to a gas.
Is it natural or evaporate?
Not quite, but you're close. What would be the solid form of water coming up this time? Yeah. What makes ice?
Frozen.
What's frozen? What do we mean by frozen?
It's cold.
It's cold, yeah. So temperature is one of the key physical things which alters the property of a substance. So if we freeze water, we get a solid. And if we warm it up, what do we get?
The gas.
What is the gas called?
Air. Water vapor.
Yes, it can be water vapour, but when it's a bit hotter, what do we normally call it? What comes out of the kettle apart from the vapour? Because actually water vapour is really little droplets of water suspended in the air. Yeah.
Steam.
Steam, yeah. So there are three states of matter. So, Olivia, what we're going to start with?
Right, we're going to start with what we call hard ice or dry ice, and a solid form of a gas that we find in the air called carbon dioxide.
Well, shall we talk about carbon dioxide?
Yes.
Well, why don't you accompany
Right.
dry ice? Here's an example of a solid which is very cold. Olivia, what temperature is that?
It's minus 78.5, so very, very, very cold
Very
indeed.
cold. And actually, if you touch this with your bare hands, it would stick to your skin and you'd get eventually frostbite and it would kill your fingers. So that's why we're wearing gloves. But it's quite interesting stuff because actually it is producing a gas. The gas is carbon dioxide. As it warms up, you can see a little bit of water vapor coming off. You may see these little pellets are flicking. See how they're rolling around? That's because they're surrounding themselves with the gas. And this is an unusual substance, isn't it?
Yes, it is, because normally what happens, say if we talk about ice, so again the fridge, it turns into a liquid, okay, but this dry ice or dry carbon dioxide skips out the liquid and turns straight into a gas in a process that we call sublimation. That's enough.
So the dry ice is very cold, about -70, and the temperature in there is plus 20, 23. So there's a very big difference in temperature. So what would you expect to happen to the dry ice, the solid carbon dioxide, as it warms up? What will happen to it? Yeah.
It'll
It'll change to
a
a gas.
Exactly.
So what I want you guys to do now is very carefully put the tops on the film canisters. Try and do it all at the same time.
Other way out.
Other way around. Yeah.
That's it.
Yeah. The other way around there. So you put them this bit, so you turn around. Turn around that way. Yep. And then you turn.
Stand and stand back.
So can you guys just move?
Stand back.
Yeah. Put your weight.
Put it on the
Put it
bed.
on the table. So turn it over. Like that. Yep. So you turn right and you want to move back, guys.
Olivia, you think it's going to work?
That one hasn't got very much in, so that's why it's a bit slower.
What's happened, of course, is that the gas takes up a much bigger volume, yes, than the dry ice. So actually, one of the ways you can make, you can change the state of matter is by altering the pressure as well as the temperature. So of course, once the gas builds up in the tube, as the dry ice releases it, so of course it takes up a much bigger volume. Now this is a gas that we're all breathing in. What do we breathe in the atmosphere? Yeah. Oxygen, and what else? What's the other gas? We mainly breathe in. It's not carbon dioxide, there's only a little amount of carbon dioxide. Yeah. Nitrogen, right.
Right, I'm going to dip this in now, okay? What do you think is going to happen? Do you want me to check? Do you want me to look at the table and see what's going to happen? Now, does anyone want to guess what's happened? What flour is mostly made up from? What Lord Winston was talking, yes, water. So what do you think's happened to the water?
The water inside so inside the cells that make up the plant, they're all frozen solid.
Something's happening to the water vapor inside.
Now look, so as it cooled down, the air inside cooled as well, and so the volume decreased. As it's warming up now, the volume increases. Will it burst now? No, it shouldn't do, because it's the same volume as it was before. So with a bit of luck, the rubber will remain intact.
Yes, it will.
You know, you could store your balloons after a party like that.